Hi there folks, Marcus from SpotX Underwater Vision here. In our last video we looked at how we can use a Pixhawk flight controller to overlay telemetry data onto our CVBS video source. So today I thought I'd share a video showing how we flash and configure the AeroMax board to get those data fields. So there's a few pieces of equipment we're going to need. The first piece is a USB to serial converter like this FTDI device here. These are available in any electronic stores or online. Second piece of equipment we're going to need is obviously our AeroMax OSD board. As mentioned in the last video, they're available from virtualpilot.co.uk, and we've got the 6 pins soldered onto the serial ports there. And the third piece of equipment we're going to need is our PC, which we use to configure the device. So let's take a look at how we hook it all up and what's involved with flashing and configuring the device. So the first thing you're going to want to check on your serial converter is the layout of these pins. And you can see on this particular device we've got ground, CTS, 5 volt, transmit, receive, and DTR running in this direction here, and they're really important to make sure that you've got those correctly set up. On the AeroMax, the documentation is really good for these, so make sure you check that specifically each time before you connect. But from having done this a number of times, I can tell you that this particular converter, and it won't be the same for all converters, but this particular one and the AeroMax board, they plug in pretty much straight in that orientation. So we can go ahead and connect that up. So now once we're all connected and we've double checked to make sure we've got no crossed lines there, no shorts, because there is a 5 volt connection there, we want to make sure that we don't connect that to the wrong pin. Once that's all been connected, then we can connect our USB to our PC and open up the configurator, flash, and configure the board. Okay, so we're now in the MW OSD configurator. This is downloadable from the Virtual Pilot site from where you buy the AeroMax boards. So the first thing we want to do, make sure we've got the right COM port. We can hit flash, and from here we want to select the most recent version. The device we're using is AeroMax, that's the OSD board. The variant we're going to use, because we're working with the Pixhawk and ArduSub, we're going to choose ArduSub. And for our particular use, we're going to choose no GPS because our flight controller is typically underwater. We're not feeding it any GPS position, so we can choose no GPS. We hit load online hex firmware. Wait for that file to download. Once it's loaded, we can flash the firmware. Will flash the board. Doesn't take too long. Okay, so once we've flashed the device, we can go ahead and connect again, making sure that you've got the right COM port there. But we can connect, and with any luck, there we go, reading done. And now we can go ahead and set up our on-screen display. Now this is a setup that I've used previously, but what we might do is just clear all of that and start from scratch. And what you can do is once you've got your display set up how you like it, you can save the settings to file, and then you can recall those settings back using these configuration files. But before we set up the device there's a few settings we might like to change. So main voltage source, and we've been using the flight controller voltage, which is the voltage reported by the Pixhawk, but you can also directly connect your battery to the AeroMax board. It will take up to a 6S battery. So if you select that, it will report the battery voltage directly. but we want to choose flight controller voltage. Auto detect, it can auto detect the cell count and cell alarm. If you didn't want to auto detect, you can set all this yourself and choose your battery cell count here and your voltage alarm here, but we just normally use auto detect. Video voltage not required, amperage not required, RSSI no, call sign disabled. Display, you can choose metric or imperial. If you were sending GPS data to the unit, you can choose the display type here. Text alarms, these are the alarms that Mavlink might send, so you want to show text alarms, they're important. All of these other settings, I don't believe that we actually use. You might find them useful, but I don't think you need to change anything else. So once we've set those settings there, we can go ahead and choose the data fields that we want. So there's 3 columns here, and that's for different pages. So you can actually scroll through and have different data setups, or 3 different data sets there. We don't use it, we just set them all up the same. We don't ever flick through the pages of data, but the data fields that we use are heading and compass, altitude, that's going to be our depth, and pitch and roll. You don't really need this, but it can be helpful if you're trying to trim an ROV or a drop camera. It'll give you an idea of how the unit is laying in the water, so it can be useful to have. Latitude, longitude, again, because our devices or our Pixhawk is typically underwater, we're not feeding it any positional data, but you can switch it on there if you need it or if you were using it. Voltage, main, we definitely need that, and everything else we can leave blank. I think we don't need to use it. No. So that's gone ahead and added all these fields. We might just move them around here to how we like it, and it's important that you leave some space here, because for both pitch, roll, and also altitude, they will show negative values, and it'll put a negative side in front, so just to stop it from going outside this safe area here, give yourself some room down the side. And it might take you a bit of trial and error to get it set up to display on your particular monitor, but this is a setup that we've used before. This works quite well on a number of different models. As I mentioned before, once you've got it set up how you like, you can save your settings to file. We've already got our settings saved, so once we've got it set up, we just need to write it to the OSD. It'll write it, it'll read it, and check that everything seems okay. That's all done now. We can go ahead and disconnect, and that's all there is to it. The OSD is now ready to connect up and use on our device.